we want to start off and talk about just user group archives and our blog. So Wayne does a good job of keeping the blog up to date with videos and presentations and additional data that kind of go along with these user group meetings. I'm going to do a quick jump out here to our website just to show that. So if you go to our blog, you can go in here and look at old user group sessions, and they're recorded. There's also a good resources section that it keeps up to date, and we do have a cybersecurity resources area. And if you go there, you have some nice hot links to Rockwell's industrial security landing page, information from ISA, Department of Homeland Security, and NIST as well. So a real good place to go for information. So please check out the blog. And upcoming events. So next month, August 23rd, we'll be doing smart motor control. So the highlight of that program will be the E300 overload. It's been out for a couple years now, but really gaining some popularity. It's got the device level ring capability, a lot more features than the E3 Plus that it replaces. So check out that session next month. And then in September, we move into Studio 5000 modular programming concepts. Modular code's been kind of a hallmark of the Logix architecture since it was introduced. But in version 24, we kind of stepped up the whole modular programming capability with more of an object-oriented approach, and we have some tools that can even amplify that. So come join us on September 20th for that, and learn kind of where things are going with the whole modular programming concept. And then October 18th is TBD. So we don't have anything on the docket right there, but this is a user group. So you all, the users, certainly can, if you want to have an idea of something that you'd like to see, shoot Wayne an email, and we'll kind of take a poll and drive that. If you don't come with anything, we'll find something. We've got plenty of stuff to do. So, but this is your opportunity to kind of drive the show, if you will. Okay, so other upcoming events, big events for us here. Houston Automation Fair. So Automation Fair, annual event held at various places across the country. It's in our backyard this year, November 15th and 16th in Houston. Huge event with large trade show floor area with all the business units of Rockwell Automation, all of our partners, hands-on sessions of the latest products, technical sessions and seminars, industry vertical summits. If you're in oil and gas, there's a vertical summit for oil and gas customers, food and bev. So just a lot of learning activities. It's a huge event. Typically 15,000 attendees at Automation Fair, so it's a big one. Definitely put that one on your calendar. Get out to Houston and go see it. If you need a place to stay there, the rentals company does have hotel rooms booked, so we have travel packages, hotel packages. We even have a nice customer event Wednesday night at Minute Maid Park with a band. So so talk to your account manager if you're interested. Get signed up. 2 days prior to Automation Fair, we have the Process Solutions User Group. So that's a user group meeting to talk about Plant PAX, its direction, learn about new features and capabilities of PAX, get your hands on it. And that's going to be November 13th and 14th, the 2 days prior. So if you're interested in that, again, reach out to your account manager. We can get you more information on that and get you signed up. Okay. So we'll kick it into this user group session. So the topic is, are you in control of your industrial control system, and how to identify operational blind spots and gain visibility into your controller layer. And this is going to be a topic that we are going to talk about. I'll be doing the first part of the presentation. Dean Bickerton with the Reynolds Company, been in the automation industry for about 25 years now, and working on Rockwell products, Siemens products. I've done some work as a systems integrator. So I've been in this automation space for quite some time. I've got Chris Grove with InDig who will be presenting with me as well. Chris is their director of industrial cybersecurity, and he'll be presenting from his home office in Sarasota, Florida. And so Chris is going to do some use cases for us later today. So he's going to go through some use cases of what if, how can you use this product to identify if someone's doing recon in your system? So kind of making the plans to attack your system. How can the InDig product help you with that? And then he's going to do another use case just on anomaly detection. So some real good pertinent use cases that Chris will go through. All right, so first off, I do want to talk about just industrial security as a whole and industrial security as a system. And for those of you that are in the process safety industry, very similar concept. You talk about layers of protection. There's no silver bullet. There's no one-size-fits-all solution. It's all about designing a system and coming up with layers of protection. So in the security world, they call that defense in depth. And there's a lot of things that you can do to get started on your industrial security journey. A lot of good resources out there from ISA, NIST, Department of Homeland Security, and again, there are various vendors out there with various products that can do certain things, certain aspects of the industrial security roadmap. You just have to kind of figure out what problem you're trying to solve and start building in the various systems to solve that. One of my favorites is what NIST has done with the cybersecurity framework. So those of you that have attended some of our ISA seminars in the last year or so may have heard some of this topic. So there was a executive order put out by the president to kind of create this cybersecurity framework. That framework was published in February of 2014, and it's currently in the 1.0 revision, and it's currently in draft at 1.1. If you go to NIST's website, you can pull down that framework. There's no charge. You can pull down the framework. There's software tools, spreadsheets, presentations, just a lot of information on it. And what the framework does, it's a great tool to kind of get you started on your journey. And so whether you're brand new to cybersecurity or you're a seasoned professional and you're trying to kind of take the next step and kind of hone your game, there's tools there that are there for you. One thing that the framework does a really good job is giving you a language so that the business people can talk to the operational people in a common language, and it's very easy to understand. So I'm just going to show you one quick slide on that. One of the pieces of the framework is what they call the core, and it identifies various functions of a cybersecurity program. And so these functions are, we're going to cover some of these today because the InDig product does some of these functions. So you have the identification phase. So it's figuring out what assets are out there. First off, what do you have? What are its vulnerabilities? And what do you need to protect? And then so then you look at the protect function and what safeguards are available for that product. Is it an old controller that really doesn't have too many options as far as protection go, and air gap is about all you can do? Or is it a newer product that does have some security functions that are built into it, but you have to go in there and configure them and turn them on to take advantage of it, like IP protection that we've introduced now in the Logix controller? If that's something that you're looking to do, you can do that through the protect function. Then you have the detect phase, where you want to identify incidents. If you are attacked, then obviously you need to respond, and so there's a lot of resources about communications and response planning, and then analysis. And then you'll see that today with the InDig product as well. Very good tool for forensics. So you have an event, you need to go back and figure out what happened and figure out how you're going to respond. You need to get your hands on the data to do the forensics for that response. And then, of course, you need to recover and get back into running your business. So again, this framework is really good. When you look at the framework, it'll actually reference various standards for these various functions and categories. So they'll reference ISA standards, Department of Homeland Security standards. Very good. Again, all free tools. I recommend you hit our website, go to the link, go to NIST, and pull the tools down and start taking a look at them. All right, so Rockwell Automation is also kind of taking the same concept of breaking down security into various functional components and defending your architecture as a system. So as Rockwell designs safety into their products, they fall in one of these 4 areas or multiples of these areas. So they're either products or functions to secure your infrastructure, so to control access and detect any unwanted activity. And you'll see that today with the InDig product. It can detect unwanted activity. Then you have access control and policy management. Again, the InDig product helps out there too. So figuring out who's doing what from where and when, and what's allowed and what's not allowed. And so some things may be allowed, but the who, what, and where may be fine, but the when might be kind of the red flag. It's like, okay, why is this guy doing this activity after 8 o'clock at night on this piece of equipment? So all those are very important pieces. You have content protection. Again, that's something that Rockwell's done a lot of work with on our controllers, on the later controllers now, to protect your IP so that you can lock that down and no one can pull it out of the controller. And then tamper detection. So making sure that our controllers have firmware in them that can't be spoofed, and our digitally signed firmware. That's something you saw come out from Rockwell in the last couple of years. But those are things that are in the newer systems. There's still a lot of older systems out there, PLC5s, SLICs, third-party equipment that don't have these tamper detection features put in them, and those are vulnerable devices that you need to protect. Okay, so with that, I'm going to get started here and talk a little bit about InDig. So InDig is a company that we started working with in January, and when I was first approached by them and told about their product, I was a bit skeptical that it could do what they said it could do. But we've since brought the product here in-house. We've been working on it since January. We've got a complete test rig set up, and we've been beating on it, and it does what it's supposed to do. So what InDig is really trying to do is just protect against operational disruptions, whether that's cyber threats or just human error. You have a contractor coming in to do some work in your facility. They AFI a rung, so they make a rung false to jumper it out on your turbine system. They go off, do something else, to forget to remove that jumper, and now you have a protection feature that's is not in place. So they're there to help with malicious intentional events and just human error, non-malicious intent, but things that cause disruptions. That's what you'll be able to catch with this product. InDig was founded in 2014. They have customers in a lot of different business segments, heavily regulated industries such as the pharma industry, some of the traditional manufacturing industries like the automotive, definitely in our area, the energy sector, utilities, water, wastewater, chemical. So they have a good footprint of customers across various industries. Some pretty impressive investors in their company. Shlomo Kramer, I don't know if anyone out there knows who he is, but he's was kind of started the Checkpoint Systems and was one of the founders of Palo Alto Systems. So some pretty he's an investor with a very keen eye. So for the fact that he's investing in InDig is a good indicator that it's a good company. Then of course General David Petraeus is an investor as well, along with some venture capital firms that are mentioned there. Locations for InDig, they have headquarters here in the U.S. in New York, and their R&D is in Israel. So if you look at the founders, the kind of the core people of InDig down below, you'll notice that they come from the Israeli Defense Force. So the Israeli Defense Force is known to be world class at cybersecurity, and so these folks got together, formed a company, saw a need in the OT space, and they're filling that need. So what they see is, if we look here at an operational network, we're kind of looking at, if you look here at these rectangles, these are the kind of the 5 layers of the Purdue model. So you have layer 0, 1, 2, that's kind of the world we live in, the OT world. Then you have layer 3 and layer 4. And what the folks at NIST saw was that there was a lot of tools up here in layer 3 and layer 4 for perimeter controls, access control, segmentation, lots of tools, lots of things that you can go out and sniff a network and figure out what's going on where. But a lot of gaps down here in layer 0, 1, and 2 in our world. So I saw kind of a lack of management and security tools and a lack of easy to implement visibility and control tools. So that's the problem that they're solving. So, and why is this important? Well, of course, everyone's concerned about a control system getting hacked and a piece of equipment being destroyed, or life injuries, or releases, chemical releases, those type things. So the one threat vector that a lot of people talk about is one that us as automation professionals know is kind of bogus. One of the threat vectors is, oh, what if somebody takes control of my HMI and tells my turbine to run at a speed to it just runs to destruction, or tries to make my furnace melt itself down by running at temperature. Well, we all know that an HMI can't just indiscriminately write a tag value down to a controller and it be accepted. Most of the times, most people have control logic in there with limits set up so that there's an acceptable range of operational parameters. So, just a straight-up HMI attack is probably not going to do anything. So here in this case, we've got an HMI saying, okay, I want you to, Mr. Furnace, I want you to run now at 9,600 degrees. And of course, your code in there says, okay, that's outside the acceptable range. Gives feedback to the HMI and says, okay, that can't happen. So if you wanted to make that furnace run at a higher temperature, you'd actually have to go in and attack the code and delete those limits that were in the code so that you could push values into that furnace and make it destroy itself. So that's kind of the more the kind of the threat that's really out there is code changes, people adding new tags, people deleting tags, deleting code out, touching the controller. So that's the piece that you really want to be concerned about is what's going on in that controller. All right, so looking at the security itself, so there's kind of 3 steps that we're going to go through here. First off is step number 1 is you need to know what you need to protect. So you have to do an asset inventory, and a lot of us do that on you might use tools like RSLinks, or you might use System Ferret, and you might have this information put into a spreadsheet. If you have other vendors or that don't have those type tools, you might be going out to panels and walking it down to figure out what you have where, and you might miss stuff. So there's going to be a good way to figure out what you have and what vintage is it. What firmware is loaded, what are the part numbers. So you need a comprehensive asset inventory. Then you want to monitor the ongoing activities. So you want to look at things that like, are people making changes to the code? Are they downloading firmware? So are they updating firmware or downgrading firmware? Do I have unauthorized connected devices? So do I have rogue IP addresses on my system making changes that I don't know about? Or do I even have kind of some strange anomalies going on where an HMI should just be doing reads and writes from my controller, but now I got an HMI that's doing code deletion, or putting a processor in program mode instead of run mode. So there's certain things that you want to monitor for, and you can put alerts in to protect. And then, as I mentioned, so then once you kind of know what you have and what type of activities you need to monitor, then you can start applying some policies. So put some common sense around it. So if this is a piece of OEM equipment that you bought and it hasn't really changed forever and you don't expect it to change, then you might want to flag if there's changes. If somebody goes on that piece of OEM equipment and adds a tag or deletes a tag or makes a rung edit. All right, so we're going to get into the system itself. So InDig has a cybersecurity platform, and it consists of a few pieces of hardware and software, and really it's software, but just software implemented on a hardware platform for ease of use. So so their software they put on a management server, so it's very easy. You just put the management server on your network. You mirror the ports, so you go in your switches and you mirror the traffic over to a port that the IMS can monitor, so it can kind of detect all the activities going on that network, and then it goes out and builds your inventory. So they have the heart is kind of the InDig management server, and then they have more edge devices as well. These sensors that could be rack mounted or DIN rail mounted sensors that could be deployed out closer to the field. So in the control panels, on the OEM skids, at pieces of machinery, so that so now you have a distributed system where you tie local equipment into a sensor, and then the sensor can then feed back up to the management server, and the management server can talk to many sensors. All right. So what does this box do? It monitors a few things. It monitors the data plane, and it monitors the control plane activities. So data plane activities are things that are very widely publicized. Modbus reads and writes, more HMI, DNP3 protocols, SIP protocols that are reading and writing, Profibus, those type things. But it also monitors control plane activities. So control plane activities are activities that are not as widely publicized. So those are, what does that packet look like when RSLogix 5000 tells a processor to go into program mode? What does that packet look like when a firmware download's occurring? What does that packet look like when someone's doing an upload? So they have they monitor those control plane activities for Rockwell devices and other third-party devices, and can tell you what's going on there. So that's the kind of the big difference between what they do and others do. And then they have the capability to tie all this information into third-party solutions like a SIM, a security information event management system, configuration management database. So they have the capability to tie this into third-party equipment. Okay, so let's look at the control plane inspection. What that does is, as I mentioned before, it's looking at the kind of the pieces of the packets that are not as well known. So these are the activities like firmware upload, download, program changes, processor condition changes, those type activities. Another thing that the tool does is the system does is agentless controller validation. So this is where it actually can go out and can interrogate the processors and can give you a little more detail about the processors, like what state are they in? Is it running, or is it programmed, or is it in test mode? What's its current firmware level? What does its control logic look like as far as the tag structures and the program structures? And has anything changed? So this is the piece that allows you to do change detection on your controller. So can look and find changes to the tag structure and changes to the program structure.
How does it know, like, depending on the PLC manufacturer, does it meet a certain specification, or
They've done
information drivers
testing on all the equipment.
Internally re-engineered their control logic. No, not the control logic itself. We re-engineered it in-house, so we're the only vendor out there who can actually speak in their language.
Okay.
That's how we're able to see it.
And when you get in the demo, we'll show you kind of, you'll see some of that.
Right.
That's all right. That's all right. All right. So here's so if you look at the InDig platform, so there's the two core pieces we're talking about: the control plane inspection and the agentless controller validation. You have the API that sits on top, and then a lot of built-in capabilities, which we'll go into. So there's
Remember, there's no magic here. We had to build that. We had to build that, right? It's not available. Each individual manufacturer has their own way of doing that stuff. The controllers speak their own language. It's not a standard. It's not a spec. And so there's no magic. We just physically had to R&D it, and that's the main difference between NIST and the rest of the world.
Right. So these are all the built-in capabilities of the product. You have asset management, threat detection, risk analysis. So we'll go through these as you see the product. But another important thing to note is that there is, third-party application integration tie-ins. So this API is open. Yeah. So you could actually, so you'll see the GUI you see is the GUI that's provided, but the API is open, and you could write your own GUI if you wanted to. So some benefits here are that not only are you getting the cybersecurity benefit, but you're getting some operational benefits as well that kind of go hand in hand. So this is helpful to kind of get a project funded and for the operational people to get some benefit out of the product. So without without just the security piece. So you're getting the real-time activity monitoring, risk assessment, the ability to do forensics. But operationally, now you've got an asset inventory, so you know what you have out there. You know what vintage processors you have, what their firmware levels. You know what their states are. You can do configuration management, make sure that that certain configurations are maintained the way that you have intended them to be maintained. And you can do change management, so you can take snapshots of controllers and can report back on changes, and it'll see code changes, tag changes. All right. So with that, I'm going to jump in here in a little bit. But so those that are here in the live audience will see we have the table that I'm sitting at is up here at the top. So this is the IMS server sitting right in front of me, and then to my left here are these several different controllers. So we have L73 controller version 24. We got an older L63 controller version 20. Get the engineering workstation that I'm sitting at. We have a brand new 5380 controller that's at version 29. A brand new HMI PanelView 5500 that's connected to it, and a Compact Logix L24 version 24. So that's sitting here, all tied in to my Stratix switch. All their activities are mirrored over to the IMS box, so it's sniffing all that traffic, and it is able to go out and interrogate those processors to pull information from those. Across from me on the area where Wayne is a sensor. So we have a sensor that's tied into a Compact Logix L30, an engineering workstation that Wayne's sitting at, another Stratix switch, and then a PanelView Plus 6 and a Compact Logix L18 version 24. So got a smattering of equipment of different vintages and types, and we've got quite a bit that we can show here. All right, so that I'm going to jump into the.
Sorry, not to cut off, but for the online guys, I put a PDF of that one line. So if you want to, you can kind of pull that up and use it as a reference to.
Okay. All right. So I just logged into the InDig server. So just a web interface, typed in the IP address of the IMS server with my credentials, and now I'm in. So what I'm just going to give you a quick overview of of kind of how the product looks and some of the capabilities, and then I'm going to turn it over to Chris. Chris is going to show you his lab where he has I've got just only Rockwell stuff because that's where Rockwell distributor, and Rockwell's the best. But Chris is going to show you a bunch of junk he's got out in his house that's non-Rockwell. So that's right. I think he found it on eBay or something. But okay, so here we go. So the dashboard. This is kind of the one-stop shop, just to show you once you get things going. This is the area that you would go just to see how things are working. You have the ability to set up alerts in the system, and so if any of those alerts are made, then you'll see them here on the dashboard. So I can just see here a nice quick controller summary. Green check's good. Yellow exclamation points is something that I've set up to be there's a warning activity has occurred there. If I had a red X, then that would be a critical warning. So just a nice quick overview here. Running tab of information, warning, and critical alarms over here at the top right. The last several activities that occurred are showing here on the right pane. So you can see here that at 10:59 and 40 seconds this morning, this
station that I'm sitting at, the 192.168.1.99, went online with the processor that's at 192.168.1.8. So, so you can see the last few activities. You can see PLC starts and stops, tag writes, tag creation, code downloads. You can see the last activities here in this pane. All right, but let's talk about what happens when you get this product and you just set it up out of the box. So out of the box, you go in and configure it. You put it on the IP address range that you have all your equipment on, and you mirror those ports over so that it's able to watch the traffic, and then it just starts finding the devices and classifying the devices for you. So, so in our case here, it went out and it found all these various controllers, as I showed on the one line, the compact Logix controllers and control Logix controllers of various vintages. It reported back the IP address that they're on. If I click on a device like this new compact Logix 5380, I can see over here an overview tab to the right that shows that it's its name that I've given it, its location that I've given it, its IP address, MAC address. When was the last time the software saw it? When was the first time it saw it? What's its state? Is it running? Is it programmed? Is it in test mode? What family does it belong to? You know, what's its part number?
Scan, that means NIST scan
Last seen, last time it's seen. Correct. It's correct. Yeah. So the ability to watch, we have the ability to see things pop on, and we have the ability to see things. You can set up an alert if you want to see if something drops off. You can set up an alert for that to say, okay, we lost this. All right. If I click over here on the General tab, I can see now also that this particular controller is at firmware 29.011. Its device type classification is PLC. You know, I get a little more information. So the just by setting up the IP address and letting the box do the work, it went through and it found all the controllers. It finds the controllers very fast. Finds controllers extremely fast, and it finds HMIs very fast as well, because HMIs are doing tag reads and writes continuously back and forth to the controller. So it picks those things up right away. It says, okay, I see tag read and write. It must be an HMI device. If it sees some control plane traffic like tag uploads, downloads, or program uploads, downloads, going online with a controller, if it starts to see those codes, then it classifies that device as an engineering workstation. So as you start, we're using the system like when I first hooked this thing up, a dormant PC just shows up as a device. As soon as I crank up 5,000 and do a download, it goes, wait, I know what you are. You're an engineering workstation. So it classifies that device as an engineering workstation. It has the various types. So you have controllers, engineering workstations.
Everything?
Yeah, it's set by IP address.
Focus is more on the controller side, but we detect everything, so you can see we categorize them
Right.
as best we can.
A gateway would look as like a device.
Yeah,
It'd be a device or an other. Right. It would look like a It would either come up as other or a device.
In fact, I'll state while we're on the subject of assets, half of our customers are really interested in the asset management piece. So even if you get the integrators out there, customers who aren't necessarily concerned right now about cybersecurity, there's no internal budget to do it. When they see the asset management piece, it's so radically different than what they've seen and be in real time that they're interested in that for now. So just keep that in mind. The product covers more fiscal areas, so it's more helpful to budget for a product because it does more things than just the cyber piece. So if you do it for the asset management, you get the cyber protection for free. I say cyber, but it's threat protection. We don't care if it's internal or external because we're looking at the actual code. It's a certainty. It's not a guess. We're not doing anomaly detection. So we're not waiting for some magic to occur because we've looked at traffic. We actually know for certain what's there. So it's a little different than what you may have seen.
All right. So there's the assets. I'm going to go into activities here. So again, the activities area is very interesting to look at. So this is just going out and grabbing all the various activities that occur. So real nice thing about the product is that you can filter. There's filters everywhere. So if there's a certain activity you're looking for, so I was showing all the activities there. If there's a certain activity like I want to see, when people go online with a controller, I can just apply that, and I can see all the times that someone's gone online with the various controllers. Maybe there's certain protocols you want to look at. Like I really want to see any anything that's SIP protocol, you could check that. Or I want to see activities that I've already classified as critical or warning or information. I also want to, yeah, you set up the policies. Yeah, you build those, and it classifies what these activities, how these activities report. That's something you configure, and I'll show you that. So these are activities. Then over here in the right pane, you have kind of the common activities. So these are activities that occur that are common to all platforms. It doesn't matter if it's Rockwell, or if it's a controller, or if it's an RTU, or if it's a DCS. These are kind of the common activities. So downloads, uploads, firmware updates, going online, going in run mode, halting. And then there's some kind of vendor-specific activities. So these are the activities that that NIST's put in that are a little more specific to the Rockwell product. So you can see those. If you had Siemens products, you can see those as well. So there's various vendors with different activities. This shows all these activities that have occurred. There is a trip counter, so this shows you all the activities that occurred ever since we turned on the box. But if you want, you can actually just reset to a certain point of time and just look at a trip counter. All right, so going now over to the alerts tab. So the alerts tab will show us all the various alerts, and again, you can filter the alerts based off of type. So if I want to look at all warning level alerts that are unresolved, I can click those filters, hit apply, and now I can see various alerts like somebody went online with this controller. So let's say it was me, I did that. It's like, okay, that's no problem, I did that. So I can resolve that alert. Okay, so now it's considered resolved. It's still there. We don't delete any alerts, but now you know it has been addressed, and somebody has said, yeah, that's okay. All right. Then you have the policies area here. So this is where you can go in, and there's a lot of powerful ways to slice and dice your policies and your alerts when you go in here and configure them. So I've got a few different policies set up, and I'll show you how you create one. So you can create policies that are only related to certain sources, so certain workstations maybe that you want to look at, destinations, certain controller targets that you want to look at, activity groups, and I'll go into those here, and actually probably better start with activity groups. What you have the ability to do is actually create asset groups and activity groups. So an asset group would be like maybe you want to apply a different set of policies to your turbine control equipment that's different from your water pump or something like that. So you might want to classify a set of equipment as a group and apply certain policies to that particular group. So I created this group here called OEM skid equipment. So when I look at that, it's just all my available assets. I said, okay, if I'm interested in looking at what's happening with this controller and these two controllers and these two HMIs. These are my OEM skids. So I can apply a totally set of policies to monitor those skids than I do the rest of my equipment. So you have the way to break up your policies based off of equipment and based off of activities, or combination of equipment and activities. All right. So before I don't lose, need to turn it over to Chris to do a use case. But another tab that's very interesting is the network tab here. This shows you all the network activity of the various protocols. So SIP protocol, UDP, TCP. If you had Profibus, you would see that here. And you can look at the activity for the last several hours, several days, and see different activities and see who your top active network active devices are, sources and destinations. Okay. Yes. Right. Yeah. Yeah. And then actually, there's some of these are on these various activities like this one. There's activity export right there. There's a button right in the system. All right.
All right, so let me do something real quick before I turn it over to Chris, and that is just to show the whole snapshot piece. So, all right, so I'm looking at my Compact Logic L24 version 30, and so this is a snapshot. So when I look at the device, there's my controller. So you're going to see some things look very familiar to you in the Rockwell world. So I drill in my controller, I can see a tag folder and a task folder. So I can go in, I can drill down, and I can see all my tasks, programs, program tags, and routines. Okay. And same with tags. So I can see these are all my controller tags up here. So I'm able to see everything that's in that controller. All right, I've got Logix 5000 open up here. I'm going to do something here. So I'm online with the controller. I'm going to delete this rung. And okay. And then I'm going to go into my controller tags, let's say. And I'm going to delete this tag called newer tag.
Will it text if you change the value of the tag?
It does, yeah. Yeah, it'll detect new tags, deleted tags, and value changes. So
But that's if you put that in your policy.
it'll detect it regardless. It will alert you if you put it in your policy. So, all right. Okay. And I'll do even a state change just for kicks. All right. So now we come back over, and I will create a snapshot. So I'm creating a snapshot of that controller, and now I see here that I have this indicating this icon indicating there's been some changes. So I can actually make it where it just only shows the changes, and I can click on that. So now I click on that snapshot, so I see that there's been a change made to this controller. I open that up and I see, okay, I've actually got changes to tags and changes to tasks. So I go here to tags. I see the minus sign. Oop, you deleted this thing called newer tag. You created this thing called newest tag. I drill down to my tasks, programs. So I'm drilling down.
About the snapshot, I want to make this clear because this is a cool point, is mostly these are done on a timely basis. Right? You set snapshots up to be at least once a day, at 6 o'clock in the morning or what have you. But what's nice about snapshots, we have a couple of customers who would say, you know what, I have vendors that come in and they have turnover all of it. I don't know who's coming or going sometimes. So when that vendor leaves, we just click on the snapshot to see what was done, how it was done. So we know for certain the kind of work that was performed, if anything was nefarious. Because we talked about before, threats can be accidental. Most of them are, in fact. But you're already in the network, right? You already got the security credentials, and that's usually the most concerning ones, right? Those are the ones that no one talks about, but those are the ones that, and snapshots will help in that area. So if there's a reason you want to go grab a snapshot, it's really easy to do. What Dean just showed you, it's very easy to do, so you can do it on the fly. But you would normally time those out, right? Certain number per day or per week, whatever fits the customer's bill.
Right.
Does it have the same kind of structure for Modicon, Siemens?
Yeah, and actually that's a great segue because we're going to turn it over to Chris, and Chris is playing with a bunch of junk down in Florida.
So
I'm
going to make.
Snapshot while we're on it is the query. That's the active part of the product that no one else is doing. So we have a passive part, which is network monitoring, but the active query is slick. I mean, that is a game we're changing of technology. That now if I have a broken the network supposed to be there.
Are you able to see my screen?
I find
Can you hear me?
Chris.
Yeah.
Yeah.
Having that information. I'm not waiting for the transfer.
Okay.
Peter's.
If it never hits the network, I'll never know about it. All I'm doing is listening to traffic on the network. We have to go out and grab that information, and that's what the snapshot's doing.
Yep. All right, so we switch over to Chris Grove. Chris, take a minute to introduce yourself. We didn't give you that opportunity in the beginning. And then go ahead and go through the use cases. And also, for our online audience, feel free to chime in with questions through the question window in the session. Since everybody's muted out, you can type in questions, and we'll try to answer them as we go along as well. Thanks.
Sure. Hi. Can you hear me loud and clear?
We hear you.
Great. Hi, Chris Carr, Director of Industrial Security at InDig. Before InDig, I worked in a variety of different cybersecurity endeavors over about 25 years. So combined with Dean's 25 years of engineering experience, between the two of us, we should be able to build anything securely with 50 years of experience, right? So what I'm going to do is walk you guys through a couple of use cases and kind of show you what Dean was just showing you with the product. He was showing you how everything works and what it does. And what I would like to show you is in practice. So in my lab over here, we call it the junk lab, I guess, because it has some non-Rockwell stuff in there. So we can go ahead and do some attacks on different devices over here and show you the effect. So what we're going to do is start with a fictitious scenario here. The first one is going to be, let's say, for example, we come into work and we start out with these emails that you see on my screen. So what Dean just showed you was looking at the audit trail and the alerts and everything, but not everything should be emailed to me. Only really important stuff that I want to respond to. So that's where I start my workday. Is today I've got these two strange emails, and I know that I don't get alerted on every time there's a code upload, but in this case it happened during production hours. That violates my policy in my plant. No one's allowed to update PLCs during production. That's the first alert. The other one is that a snapshot notification, that one of my snapshots have changed on one of my turbines. So what I'm going to do is come into my InDig console here and start at the beginning and kind of take a high-level look and see if anything looks suspicious, if any of my alerts match up if any of my emails match up to any activities and alerts. So because so we're going to cover two different things here. One of them is, what does it look like when malware hits the environment, and what's that reconnaissance phase look like? And then the other one is anomaly detection, because technically malware should cause some anomalies in our environment, so there's a lot of overlap there. But also things that are mistakes. Engineers might type a wrong IP address. We may have somebody not even have the correct code to download to the controller. We might have a variety of different human errors that could happen that could be anomalous, and we could detect. We could also detect cyber incidents and things like that. So rather than just kind of talk about it theoretical, I want to walk you through a couple of these use cases in my fictional environment here. So if we imagine for a second that we're dealing with a state-of-the-art facility that's got a lot of people coming and going all the time. There's a lot of system integrators. There's a lot of programming, of reprogramming and updating and management of a lot of industrial controllers. So there's a lot of unknown people, unknown changes, and machines that come and go in and out of the OT environment. And that could be a little bit complex to manage. So what you'll need is a solution that does a good job of looking at all of this and making sense out of everything it sees. So it's not just being able to say, hey, there's a new workstation. You need to know that this is not really interacting with my OT systems. So it's just a workstation probably in the conference room versus one that is sitting on a network and actually doing a code download or a code upload. So first we had our emails with a couple of strange devices appearing and some snapshot changes. So just going to start my high-level investigation on our assets screen and just kind of scroll this really quick and look for anything that might look strange. So I could see all my industrial controllers here. I've got my chillers and robots and RTUs and turbines and stuff and generators, and everything looks normal here. As I scroll down, I start to see some unnamed devices. Unnamed means that InDig has not really figured out who it is. It's not DNS. It's not really responding to our request for information, so we kind of are suspicious about those. So I'm going to first just take a quick high level and look and see how many unnamed devices and where they are. I can see that 10 days ago I had a few. Maybe I know these because that's my conference room segment. But I do have these two very strange engineering workstations now. I've got an unnamed 128 on a weird IP range. He came and went in a minute. So this guy only lived for 1 minute on my network. And then on my actual operations network, I've got a new guy now, unnamed 129, who stuck around for a few hours there and we don't know what he did yet, right? But it is very suspicious that we've got some people on our network that we don't really know what they're doing, and they're not really yet supposed to be there. So I'm going to put that aside for just a moment. Let's put a pin on the unnamed guys because we're about to come back to them. Let me just take a look through here, and I can see some other strange assets. I've got an HMI, and I've got an engineering workstation with some strange 188 IP range name. It looks like a Russian address. And let's see, what else do we have? I can see my historian, and I can see my SCADA servers, my operations center. Everything looks normal. I can see my switches, everything that looks okay down there. And then I can see a couple more unknowns, just workstations and things. But what really worries me is the new HMI and the new engineering workstations. So let's jump into our activities now. And because we're hunting malware, let's first start by looking for activities that are indicative of malware. So if we think about it, generally it's going to hit something like the Windows. That's the most common malware target in the world, I think. So that would probably be the first implant on the network. And once the malware realizes that it's got OT networks around, it's going to start to interrogate that network and look at the devices and ask for things like firmware versions. So there's a few different techniques to grab that information, but most commonly we see things like a hardware configuration upload, firmware uploads, or code uploads. So in this use case here, we're just going to, we can see that we've got, I'm going to scroll back in time now, down to going back into May, and I'm looking in the activities trail here. I've got timestamps on the left, I've got the activity, the source and the destination of all this, and then the protocol that was used. And going back in time, I can see I've got my engineer 3 and engineer 6 and my remote engineer. All these guys are doing these activities, code uploads. This all looks pretty normal to me. This means my engineers are working on that day. A week later, they kind of do the same thing. And as I scroll up, I start to go through time, and I'm starting to see all the activity, and I can kind of get a pattern for what it should look like. And then I see this strange piece right here. On 7/9, that unnamed 128 machine did a code upload from my HMI that's connected to my safety system. That is not something that should happen. A new node on my network, and second, that safety HMI is something that no one should be touching at all. I should probably even get, try to do another alert for somebody touching that. And then I can continue up to the audit trail and see that there's some other suspicious activity here. I can see this unnamed 129. See, this was the 128. This is the guy that came on the network right after. And he did some stuff. So now I can see that there's definitely some malware activity happening on my network. There's code uploads coming from suspicious nodes that shouldn't be there. So I'm going to turn around now and switch the way I'm looking at my activities data, and now I'm going to chase the malware from a different perspective. I'm now going to look for any industrial activity done by an unnamed machine on my network, because that would be extremely anomalous, right? Already, clearly, I can see that there's stuff happening here, but anything unnamed is suspicious. So I'm going to close out that filter and just start filtering on unnamed. And now I'm getting a lot clearer of a trail of what has gone on here in my environment. I can see that this new node went online with an HMI, uploaded the code, then reconfigured the safety system with hardware and code download, and then right afterwards, about an hour and a half later, I have the same thing happen on a chiller, and my chiller, by the way, is a Rockwell device, and now I've got that same node talking to my turbine, which is a Siemens device. So that's even more suspicious now, because I don't really have the same guys working on both, but they don't use the same workstations for that. I'm pretty careful in my environment. My Rockwell guys work on these workstations, and my Siemens guys work on those. So I've got a couple of suspicious things to look at in my environment, and I'm going to remove all the filters, and I'm just going to go all the way back in time now, look at my entire activity trail for a second. Okay? I don't know if you guys have looked through lots of logs before. try to do the same here. I'm just going to kind of scroll, and let's just watch and see what people are doing. You can see a lot of engineering activities here. You can see my engineer remote. You can see that we've got normal activities. There's my field RTUs on the right, engineering, all engineering activities. And then, wow, there's my HMI touching a robot and doing a firmware download and a PLC restart. I would probably investigate that as well. And that happened back in May. So this could be my infection point for my malware. This is the first time something suspicious happened, and I know that HMI1 is a Windows HMI, and I also know that they get on the internet often to get the latest stuff for their robot. So I'm going to just keep scrolling through time kind of quickly here, and let's move up into where we feel like we started to notice some equipment malfunctioning around the 4th of July. And you can see here we still have that HMI doing stuff, and I'm just going to come up until we get to, that's all June activities. Again, it's a lot of engineers doing engineering activity. And I'm just going to keep scrolling up, and we're about to get to it. Don't worry, I'm not going to, there we go. So on the 4th of July, or the 9th, the start of the 9th, we can see that I've got my engineer working on a generator. I can drill down and see the code that he's done. And shortly after, I've got this strange IP address on this other network. And then I've got my unnamed machines appearing all of a sudden. And then shortly after, now look, it starts to get really odd. Here's that Russian IP, the 188 range. Now I see my corporate firewall doing engineering activities to my RTU. And then my engineer 6 is now on that Russian network. So someone basically hijacked engineer 6's workstation, moved it over to a Russian network, and I was also using my firewall to communicate with my devices on my network. So this is a clear indicator that there's an infection that's happened. So what I'm going to do now is jump into my chiller, because I do see that they affected both my chiller and my turbine. So I'm going to hop into my chiller here, and you can see I have all my snapshots that Dean showed earlier. But I'm just going to look at all the changes in my environment. Let me go to the first snapshot I ever did. You can see this is May 25th. And I'm just going to take a look and see what my code should look like. Everything on the first snapshot is new, so it always has a plus. So this is what my chiller code normally looks like. It's pretty simple. All it does is it reads an input and it adjusts the fan speed accordingly. There's not a lot of rocket science to that. And let me go and see what I have today. And I go into my chiller, and I'm going to filter just on, let's just show everything real quick. Now you can see I've got quite a different program here. I've got my hacked temperature tags that are in there. I've got a deletion of new temperatures. I've got quite a bit of new stuff and things that, including my safety system, that has been completely rewritten. The main routine has been modified. I've got a hacked safety system that's in there now. They probably are using that instead of the real one. That's why they changed the main routine. And I can see I've got a whole new set of tags. So there's a good chance that was a cyber attack. And like Stuxnet, there's probably a false feed going back to an HMI now telling people that the temperature is okay, when in fact it's not. So I've done all this through using a combination of policies that Dean showed you earlier, as well as asset policies. So some of them tell me when new equipment is there, some of them show me the activities that are going on, and I've created an activity trail that shows me everything from the malware touching that network back in May, to the infection that happened in July, to the full-blown invasion of my network from Russia that just happened on the 11th. And all of that stuff reflects back here to the dashboard, and the first time that I logged in, I would have had a lot of red X's up here that I would have jumped in, like field RTU 176. I would have logged in back in July 4th and seen that I've got these alerts, dangerous activities. So that's why we bring everything out to the dashboard here, is to alert you, to let you know that back behind the hood here, there's stuff going on that you should look at. And with that, I think I'm going to stop here and open it up for Q&A. And Dean, is this a good time for you, or is there something that you wanted me to touch on?
No, I think that's good. I think we'll open it up for question and answers. Wayne's kind of manning the console there, looking for anybody that's typing in questions. If you have any questions in the audience, Wayne has the mic as well.
Yep. Web audience, feel free to type in. I don't know if I can unmute your line or not, so just go ahead and type a question in. And do we have anything else in the room, Kevin?
Where does it, the memory, where does everything go, the alerts and everything? So
Yeah, there's memory on the server itself, and then it can be tied into the to third-party systems as well.
Like to your, like a network drive after a certain memory?
It would go to another device that not the way you're saying it. It would actually go to like a SIM or a configuration database management system. But you could, if the GUI, the API is wide open, so you could write it to where you could write it to a third-party device as well.
Open, clean, but there's a lot of memory on this device. You'll get years of memory in typical. How many years depends on the network specific, but you'll get years of backup.
Yeah.
On that. It saves a lot of data.
Yeah, so you got a lot of local storage, and then you can offload
There's
it.
ways
Right.
to offload it. We can work with customers on how to what's best for them, but there's ways to offload it.
Right.
Yeah, we got a question from the audience about the sensor. How's the sensor work?
Okay.
Chris.
Chris, grab that
Chris, you
one.
want to take that?
Sure, absolutely. Yes, the sensors are basically designed to be just a traffic collector for us. So what we do is we deploy those down at the industrial switch level so that we can see traffic in like the nooks and crannies and some of the dark corners of your network if you have risks down there that we're trying to mitigate. If all you care about is looking at what's coming in the front door, like from the IT department or from the firewalls to connect to the internet or whatever, then we probably only have to sniff one part of your network. But if we need to get down into those other areas, the sniffer gathers traffic that comes off of a mirror port, filters out the stuff we don't need, compresses it, then encrypts it, and it sends it over the IP network back to our management server that does the analysis on that. And that's all that a sensor does. It's a traffic gatherer and filter.
Well, thank you.
The mirroring of ports, does that slow down the network?
No, because it's not. So that's a very good point. And so it's not a pass-through device. It's just hanging off, monitoring traffic that already occurs.
We're just monitoring,
Yeah.
not adding any traffic to the network. We're just listening.
Right.
I think it's kind of a similar question online about the snapshots. Is any
That one, the snap gets on the network.
Database,
Right.
but the packets are quite small, and we're only looking at the changes, right? So we're looking at comparing the changes. So it's not a tremendous amount of traffic there, but these are small packets.
Right, and I'll kind of say something to that as well, in that the query is really not much different than RS links. You know, if you were to links and browse the network, yeah, it's very similar. So yeah, it's very light data packet.
What we're doing is if we're in a Rockwell environment, we're talking to Rockwell. We're talking their length, right? We're not a third party trying to extrapolate some magic out of the device. So because we've rewritten this code, we re-engineered this code to be their code. So we literally talk to Rockwell like we're a Rockwell device. We'll talk to Siemens like we're a Siemens device. And each of them have their own inconsistencies that make them give certain information back and forth. They all have these little magic packets that they like to use. And so we look like one of them. So I just want to make that point clear as we're talking about traffic. So we're not looking like we're not adding any more data than we would another device asking for that information.
Right. And another question online, I think this is a good question actually too, is can you revert the snapshot? Can you use this system to revert to a snapshot, or is it just basically providing that history of change? And
Yeah, no, it's just giving you the history of change. Yeah.
Is that a backup question?
correct.
Yeah.
Correct.
Yeah, backup would be in the Rockwell world.
That's a conversation we probably need to pull offline, but
Yeah.
we can help with backups.
Certain vendor you have
Right.
that on certain vendors, certain models, you can do backup
But there are things
capability.
that are easy to do,
Right.
certain things that would be harder lifting to do that we could have that conversation. Because that would be network specific questions, I think.
Yeah, I think it's device specific
But we
and
do a lot
yeah.
with backup support. I mean, that's what device is designed to help with backups. We're not a backup device, so to speak. In other words, we're not going to go and do the backup, but you can use our data for backup currently.
Okay.
I don't know if that answered the question, but it may be one we want to pull offline.
Yeah, I think we can move forward. think in general the snapshots are there to really just kind of provide that history of change. I think probably the general answer.
Yeah, and remember, it's a change that's also local, right? So someone locally walks into that machine. There's no other way to get that information. I want to make that absolutely clear to the audience. There's no other way to get that information about a local a threat or a change other than going to the device itself, right? So if it never hits the network, no anomaly detection or network device is going to see that traffic. It doesn't exist. And every successful known hack, whether it's Stuxnet, I know we all hate to hear that word, Stuxnet or Ukraine, they were all done that way. They went in locally and made a change to the control logic so that then they can make a change from someplace else. But you have to be able to get to that, and most people have secure firewalls. They have a lot of things to prevent from the outside coming in. But a lot of threats are done from the inside, the successful ones. Now, there's obviously a lot of errors that people make in companies where they don't advertise those issues when they go down because of an accident. But there's a lot of those cases that occur, and we can help with all of the above.
Yep. Yeah, I think you said at the very beginning, a lot of times it's just, it's may not be malicious intent, right? Just an inadvertent thing, so you completely detect that. I don't think I see any more questions online. I know we're a couple minutes past our normal stopping point, so we'll give a last chance for questions online as well as in the room. And once again, we have pushed the envelope today beyond what we normally can do. We got a lot of stuff working, and amazingly, it worked well.
We can take it to you
on the internet side, not the actual stuff working in real life. It's just to be able to demonstrate it online is always a challenge. So,
yeah, if you couldn't be here live and you want to see this equipment in operation, feel free to reach out to me or Wayne, and
yes,
we have it here. So
we are fortunate enough to have the InDig IMS and a sensor that'll be here in New Orleans, so we can recreate this lab and demonstrate it to you guys at any time. So, good point. All right, as always, we thank our web audience for joining remotely, and for our local guys too for coming out and getting away from your computer desk for a few minutes. So, thanks again. Thanks, Dean, Chris, and Peter Rotundi, who was also talking. We didn't introduce him, but Peter's a local InDig business development manager. So, all right, we'll close it out. So, thanks again.
Thanks, everyone. Take care.